Have you ever heard the words tissue culture being thrown around, but really you have no idea what people are even talking about? Perhaps you have heard of tissue culture, but you really don't know how it's done? Then this is probably the video for you. Hello everybody, glad you could make it. My name is Kaylee Ellen and welcome to Tissue Culture 101. In this video, I'm going to take you through what tissue culture is, why it is happening, and even show you how it is done. So we've got quite a lot to get through. Before we begin, I just want to let you know that a lot of what you're going to see in the demo today, where I actually show you the tissue culture, has been simplified down quite a bit. It's a non-technical overview and it has not been performed in laboratory conditions. So let's jump straight into it. What is tissue culture? Tissue culture, also known as micropropagation, is the process whereby we take a plant and we produce clones of it on a mass scale. So we're talking thousands of clones, not just a little bit of chop and prop. This process is known as a protocol. So how popular is tissue culture? Well, it's actually way more popular than you might be thinking. When you go to big box stores, 80 to 90% of the plants in those box stores are tissue cultured. So that's quite a lot. That's also why you can't actually find rare plants in big box stores. That said, even plants that people consider to be pretty rare have also been tissue cultured or are in that process of being mass produced. Plants such as the Monstera Thai constellation and the Philodendron Pink Princess have both been tissue cultured. That is why, of course, we now refer to these plants as being in high demand rather than rare. There are a few others, of course, in tissue culture production. There'll be many, many more than what I'm about to mention, but during my trip to Thailand very recently, I found the following plants in tissue culture. Plants such as the Philodendron White Knight, Epipremnum Cebu Blue, Philodendron Florida Ghost, even Philodendron Tortum, Philodendron White Wizard, and even Monstera epipremnoides. I found all of these in tissue culture on my recent trip, so they are coming. There's some inside scoop for you. These plants are coming. Of course, there will be many, many, many more plants in tissue culture that I haven't mentioned, but just so you know, this happens on a much wider scale than a lot of people are actually aware. So how do we get to this point? What happens with rare plants when they hit the market? How do you go from a plant being really, really hard to get to being basically everywhere? So in order to better understand how this works, let's look at a brief example. So let's use the Philodendron Pink Princess. In the beginning, there weren't that many Philodendron Pink Princesses on the market. This is not because they were necessarily rare. It was more a case of there was low demand. People didn't know about the plant. People didn't necessarily want the plant. The plant wasn't fashionable. It wasn't getting press. No one had really heard of it. What then has happened since is people started to become aware of it and the demand starts to increase. Over time, demand is going to increase more and more and more and more and more, and the prices are going to go up and up and up and up and up, till you reach a point where we're currently at the moment with Philodendron Pink Princess, and that is that the price is at an all-time high. Same with Monstera Thai constellation, and we're now at the point where tissue culture is occurring in order to meet this demand. Once tissue culture has occurred on a huge scale and plants start filling people's homes and everybody has the plant that they've all coveted so much for so long, these plants become not in as much demand because everyone has one, they're not rare anymore, and the price will start to plummet, and the value of that plant will probably never go back up again. That is it for that plant. It becomes a common houseplant. Obviously, most plants are probably going to work this way. Most plants are probably going to follow this journey into the market. So prices will peak, demand will eventually be filled, and you will start seeing, for example, a pink princess in IKEA or a big box store within the next 3 years. No problem. Okay, so you might be thinking, well, right, what's tissue culture got to do with that? And the answer is tissue culture is the only way that any supplier, any, person in the industry can produce plants at this rate to meet this demand. Using regular methods of, chop and prop, regular propagation is nowhere near fast enough. to meet the demands of the market. It just cannot be done. If protocol from tissue culture is successful, you can clone one plant into thousands very, very quickly, very easily, and in a very cost-effective manner. The methodology used to do this is usually a trade secret. For example, when I show you the demo in this video of myself performing tissue culture, I'm not going to divulge any of the recipes for any of, the growth media needed to do this. Now you're probably thinking, well, why? Why is it secret? Why don't you just tell everyone so we can all work to make these plants less rare? And the simple answer is, it's business. It's how all of these companies work. Each species of plant being tissue cultured, even down to the type of plant, probably, maybe, requires its own unique protocol. What do I mean by that? So if I'm saying a Monstera, Pinnati partita is to be tissue cultured, and a Monstera adansonii is to be tissue cultured, those plants may not have the same, recipes, the same protocol. It might be entirely different. And to find this out takes a lot of time, and it takes a lot of money, and it takes a lot of research and manpower. So if a company happens to crack, how this is done, the last thing they're going to do is share that information. So if company A, figures out the secret to tissue culturing obliqua, which I suspect has probably happened as we speak, they are not going to release that information to company B that comes along and says, why don't you share this information? Why don't you tell us how it's done? This is very similar, to be honest, to asking a plant shop owner where they're getting their plants from, who their supplier is. It's kind of the same thing. Because if, one lab managed to get a hold of another lab's protocol, they could quite easily steal all the revenue from the lab that did the original work and steal their commercial success, which of course is what nobody wants. Think of it as protecting a product, or think of it as protecting intellectual property. It kind of works the same way. So how do you actually tissue culture a plant? What do you actually do? What are the steps? What generally happens is the growth material is prepared along with the plant material that is going to be used. The plant material is then placed into the growing medium, and over time, the plant will multiply within the medium. So if you have, a node on a Monstera that you're shoving in there, over time, this plant is going to start sprouting multiple shoots from this original plant material that you've placed in this medium. Once there is a significant amount of growth, these plants are then subcultured, which basically means they are divided up. So all of these shoots that have grown from this original material are separated. They are then placed into new media, new growth media, and this process is repeated. This process is repeated until the desired quantity of little plantlets are reached. Once this process is complete, the plants are divided again and placed into new growth media. Now, this growth media is usually full of hormones, chemicals that stimulate root production. So the shoot production actually happens first before the root production. So it shoots before roots. Once these roots have developed, the plants are removed, and then they go through a hardening process where they are basically acclimatized to our surroundings, because these plants have actually been grown in lab conditions, not our conditions. Once they're hardened off, of course, these plants will visit a greenhouse, they'll be potted up, and they will be grown out from tiny little plantlets from there on forth. So they're now ready to be grown in a regular nursery and sold on as houseplants. Now then, so tissue culture is usually performed by, large companies, large corporations, but there are a subset of people, hobbyists, that do like to try and perform tissue culture at home. This process is often referred to as kitchen culture because, as you may suspect, a lot of this protocol is actually carried out in a kitchen environment using kitchen materials. So think of it as kind of like the Breaking Bad of tissue culture. That's what's kind of going on in the minute. It's not the easiest thing in the world because you have to fight with sterilization and keeping the environment clean, but it can be done. And kitchen culture is essentially what I'm going to show you now, so please bear that in mind. It's not in lab conditions. It is basically Breaking Bad with houseplants. So for this demonstration, I'm actually going to be using the Monstera adansonii nodes. Now, why Monstera adansonii, you might ask? Basically, I own a Monstera obliqua, and I am not about to screw around with really expensive plant material. when I can actually experiment with the protocol on plant material that is much cheaper to find. So that is why I'm actually using Monstera adansonii. Depending on the type of plant, of course, tissue culture can be pretty successful using different parts of the plant. For some plants, it might be the leaf. For some plants, it might be the stem. For some plants, it might be the nodes. It really does depend, and what works well for one plant doesn't always work best for another. That is why we have to spend a lot of time in research looking into this and working out what is the most efficient way to clone a plant. A very quick note on sterility and just generally having sterile conditions. So tissue culture, the environment that we use for tissue culture and the conditions that these plants are grown in is absolutely ideal for any fungus and basically mold. And the problem is mold and fungus will actually multiply quicker than any plant material in this environment can grow. So if we get any contamination in there and any mold or fungus in there, it's pretty much game over because it's going to multiply quicker than the plant can multiply, thus killing the plant material. So it is so important to keep things really, really sterile. In terms of kitchen culture, that usually means a lot of alcohol spraying and a lot of glove changing and a lot of wiping things down. In this video, however, I do have a little bit of a helping hand. I do actually have a laminar flow hood, so that does help keep a lot of things sterile. In a lot of conditions, in kitchen conditions, you wouldn't necessarily have one of those. So I do have increased sterility there that perhaps a lot of other people might not have. But of course, it's nowhere near as sterile as a lab. So without further ado, let's get into it. As I mentioned before, in this demonstration, I'm using a laminar flow hood. These are used in laboratories to produce a clean flow of air that passes over the medium inside and keeps it free from any airborne contaminants such as spores and bacteria. The first thing we need to do is prepare the growth medium. For this, I'm using MS, which is essentially a mixture containing all of the essential growing chemicals for these plants. To this, we add a little carbohydrate in the form of everyday sugar, growth hormones, and plant preservative mixture. Plant preservative mixture, also known as PPM, is antimicrobial, which means it helps prevent any potential fungus and bacteria growth inside our tissue culture containers. Once this is mixed, I'm giving the solution a quick shake in order to thoroughly mix the ingredients. I'm then going to check the pH. Now this needs to be between 5.5 and 5.8 in order to ensure we have optimal conditions for nutrient uptake. Should we find that our pH isn't quite where we'd like it to be, we can always add a little bit of vinegar if the solution is too alkaline, or bicarbonate of soda if it's too acidic. This should bring the solution to an acceptable pH that we can work with. I'm checking the pH again, and as you can see, we've raised it just enough for it to be acceptable. Now that we're good to go, I'm measuring around about 45 milliliters of our prepared solution into our tissue culture container. To this, I'm adding agar, which is basically a vegetarian gelatin substitute produced from a variety of different seaweeds. This basically makes the medium firm and allows the plant material to be suspended. After giving this solution a little bit of a shake, I'm going to boil this solution in the microwave. Now, in laboratory conditions, this would likely be done in an autoclave. However, this is kitchen culture and I don't have an autoclave, so microwave is just going to have to do. Normally, of course, I would allow this mixture to cool and solidify on its own, but for now, we're gonna have to go with a little bit of a here's one I made earlier moment. So, here's one I made earlier. Okay, onto the plant material. So in order to prep this plant for tissue culture, we need to clean and remove any debris from the plant. We only need the nodes in this case, so here I'm removing the leaves to help reduce any risk of contamination. I'm chopping this plant into nodes. Now this doesn't need to be done in the laminar flow. In fact, it's probably best not to, as we haven't sterilised any of the plant nodes just yet. This way we can keep our tissue culture area clean and contaminant free. It's time to clean the nodes, so I'm washing these in a solution of 10% bleach, a little bit of water, and a little drop of dish soap. Now why dish soap, you may ask? Basically, it breaks the surface tension of the water surrounding the plant material, which allows the bleach solution to penetrate all the nooks and crannies and sterilise the plant material. I'm going to leave this to soak for around about 15 minutes or so, and I'm going to agitate it every few minutes just to make sure everything is nice and clean. Okay, here we go. It's now time to perform the actual tissue culture procedure. Here we are inside the laminar flow hood with everything we need to carry out this process. I've changed my gloves and they've been sprayed with 70% alcohol, as has all of the equipment in the laminar flow that you see before you, so it is all sterile. I'm taking this node in my tweezers and I'm dipping it into 70% alcohol solution. This is basically a final attempt to kill off any remaining contaminants that the cleaning solution just didn't quite get. I'm now rinsing the node in sterile water and a little bit of plant preservative mixture just to wash off any of the alcohol, any of the bleach, anything that is left over on this node. I'm placing it onto the chopping board and I'm trimming off either end of the node. Now I'm doing this because basically the alcohol and the bleach will have probably killed off all of the outer tissue on this node. And in order for tissue culture to work, I need fresh, sterile tissue. So cutting off either end of the node is basically exposing that tissue. I'm opening my growing container on its side to further reduce any chance of contamination, and I'm placing the plant material into the agar. Now, honestly, this can be a little bit tricky, especially for me in this demo, as my tweezers just aren't quite long enough to use on these containers. So, as you can see, it's a little bit fiddly, but I do get it in the end. Now that the plant material is inside the agar, I'm shutting the lid nice and tight. And there you have it. There is your prepped tissue culture plant. So this is basically what that container looks like up close. Now I do appreciate it's not the easiest thing to be able to see in there just due to the way that it is, but the node is sat there in agar, hopefully in a 100% sterile environment, so that it can start to basically propagate itself and create new shoots. So what you just saw there was the very first stage in the tissue culture process, because of course the medium that I placed that node in, or those nodes in, does not stimulate root production. From this state that I just showed you before to actual root production is going to take several months. It's not an overnight thing at all. But basically, if my trial was of course successful, I would then be subculturing these plants once, enough shoots were developed, and then I'd be placing them back into the same growth media again to let them subdivide and produce more shoots again. I would then subculture again. Once I reach the desired quantity, that I'm happy with, I can then take these plants out and put them in a new growth media that would of course produce roots. Once this is done, of course, I can continue hardening these plants off, probably in my office, just to see how they do. I might have some losses, who knows? These plants are being grown in essentially test tubes, so they're used to 100% humidity, just great surroundings, totally sterile environment. Moving them out of that can, cause a few to drop. It's just what happens. But once these plants are hardened off, they're free to be potted up and put into soil or coir or whatever it is I'm going to use, and grown out from there. If the trials I've shown you today are of course successful, I will totally do a follow-up video showing you, the rest of the process and just how everything's gone and the results in a few months' time. But it will be a few months' time. I hope this video today has answered some of your questions on tissue culture, maybe let you know a few things about tissue culture and what plants are coming onto the market that are tissue cultured. And I also hope you got to see a bit of a sense on how tissue culture is actually performed. And that concludes this video. Thank you very, very much for watching. Please leave any questions, comments down below. Feel free to follow my Instagram at KayleeEllenOfficial, and feel free to subscribe if you'd like to see any more of my content. Thank you very much for watching, and I will see you next week. Bye guys!